The dimension table is nothing but the textual description of the data. It store the textual information. Textual description of the data is going to store into the dimension table. Okay, so we can't able to aggregate these dimension tables data. Okay, the example: dim customer, dim product, dim org unit, dim date titles, dim vendor, dim employee. These are the few of the examples of the dimension tables. Okay, let's come to the fact table. So fact table is nothing but the measures of calculated interest. Means it's going to store the numerical data on the fact table. Along with the numerical data, it's going to store the reference keys of the dimension table keys. Dimension keys table reference keys means foreign keys is going to store into the fact table. Okay, so examples of the fact tables: fact sales, fact inventory, stock ledger, plan sales, and then purchase order. So these are the different examples of the fact tables. Okay, so and then come to the dimension models. So the dimension models is going to mainly build the data warehousing projects. So a kind of star schema and then Snowflake schema. Other schemas also there: Galaxy schema, fact consolidation schema. So those are not that much important for us. Okay, so if you know, if they ask what is the dimension models, then you can say, so in the dimension model they are going to use any one of the star schema or Snowflake schema. They are going to build the data warehousing project. So what is meant by star schema? Okay, a star schema is a one fact table is connected with the multiple dimension tables. Okay, star schema is nothing but a fact table connected with multiple dimension tables. Either it could be one or more dimension table is going to connect the fact table. It's a look like a star, that's why it's called as a star schema. Okay, advantage of the star schema means is we can able to easily understand the star schema. Easily understand the star schema. What is the disadvantages means the query performance is going to decrease due to the huge amount of data is going to store into the dimension tables. And day to day is going to store the data, the table size is going to increase, then automatically the query performance is going to decrease on the star schema. Okay, come to the Snowflake schema. Okay, the Snowflake schema is an extension of the star schema. So the dimension table is split into multiple tables. A fact table connected with the dimension table, that dimension table can be split into multiple tables, multiple dimension tables. Okay, here they are going to generate the hierarchy between the one dimension to another dimension tables. Attribute level hierarchy is going to generate here. Okay, next will be, so the advantages will be, so the number of lookup tables are more, so the data, the query performance is going to increase by using the joins. Is going to increase the performance. Query performance is going to increase. Next disadvantages means, so it will be easy. You can't easily understand this model. It's difficult to understand, and then cost and effect also, time effort and then cost also is increased for this model. Okay, to build the number of lookup tables and more. So that is the reason cost and effort is increasing in the Snowflake schema. So these are the advantages and disadvantages of the star and Snowflake schema. Clear guys? Any doubts till now? Any doubts guys till now?
Sir, please tell me once again Snowflake schema, sir.
Yeah, the Snowflake schema is for example, take one fact table. So this is the one fact table. Okay, this fact table is connected with the multiple dimension tables, right? That is a star schema. For example, take like this. This is a star schema. We are going to connect the multiple dimension table in the one or more dimension tables in the fact table. So like that we are going to connect it. So it's look like a star. That's why you call as a star. The name it came the star schema. But come to the Snowflake schema. A star schema is an extension of the Snowflake schema is an extension of the star schema. Means the fact table connected with the multiple dimension table. These dimension tables, whatever the dimension tables are there, these will be splitted into multiple tables. So like that. Okay. So in the star schema, all the dimension, the same category of information is going to store into one table only. But now this table can be splitted into multiple tables. So like this. Based on the requirement, they are going to split the table. This single dimension table, they are going to split into multiple tables. Okay. Means the data is going to split into these all the tables. Then automatically the query performance is going to increase here. Where the data is here 100 GB is there, the same 100 GB is going to split into multiple tables here. Means automatically the query performance is going to increase. Clear? So like that, this dimension table can be split into multiple tables. Here the hierarchy means this table to this table, they are going to generate the hierarchy relationship. From here to here, they are generating the relationship. Or this table to this table, or this table to this table is going to generate the hierarchy. Yeah, you can see here. Are able to see the screen? So dim store is split into dim geography. Okay, here dim product is split into the brand table is going to brand information is going to store into the separate table, and category of information is going to separate the one more table. So here you can see the guys the relationship here, the brand ID to ID. This is the primary key, this is the foreign key. So they are going to give a join dim product dot brand ID equal to dim brand dot ID. Like that, they are going to give a relationship these two tables. And then here also the product category and the ID they are going to give a join. Here, so the same product table is going to split into multiple tables. So here the all the brands information is going to store into here. Here category of information is going to store into here. So like that is going to store. If you want still example, like best example, I am going to show you how they are going to split the Snowflake schema. Yeah, see the requirement I am going to show you how they split it in the real time. Yeah, you can see guys, this is a product dimension. So this product dimension they are going to split it into these many tables, small lookup tables. So company level, division level, group level, department level, sub department, class, subclass, item, SKU item. Okay. So the same one dimension table they split it into how many tables? I think 1, 2, 3, 4, 5, 6, 7, 8 tables they split it. Clear guys? So like that they are going to split into the multiple tables. So the location dimension how they split it in the real time I'll show you. Yeah, this is the location table. See, the location table they split it into the country, state, city, location, or another tables also they created chain, area, region, district, location. So these many tables they split it in the this location dimension table. Here the relation between they are going to generate the relation one table to another table. They are going to give you a join. Okay, that is happen in the Snowflake schema. Clear guys? Any doubt here?
Understood, sir.
Okay. So now we will going to discuss with the types of the facts. Fact types we are going to discuss. Okay. So fact types. So there are the three types of the facts are there, guys. So fact means we know what is a fact. So it's a numerical data is going to store into the fact table is a fact, right? So there are three types of facts are there. One is the additive fact, semi-additive fact, non-additive fact. Okay, there are three types of facts are there. One is the additive fact, semi-additive fact, and non-additive fact. Okay, so first we'll discuss what is the each one. Additive fact, what is the semi-additive, what is the non-additive. Okay, so additive fact means, for example, I'm going to explain the with diagrammatically. Okay, guys. So this is the fact table. Okay, this is the fact table. So the fact table name contains the fact underscore sales. Okay, I'm going to give fact underscore sales. So I told what kind of information is there in this fact table. So the reference keys means foreign keys is going to store into the fact table along with the numerical values, correct? For example, product ID. I'm going to give a product ID. Okay, location ID. These are the keys, reference keys, business keys. Okay, and then date ID, and then quantity, sales quantity, okay, and then sales amount.